Good morning, and thank you for taking the time out of your day to listen to my presentation. My name is Jeffrey Lugo, and I'm with Material Sciences, LLC. Today I'll be discussing a program that I've been leading entitled Efficient On-Craft Composite Repair Process. First, I'll start off with a brief introduction to my company. Material Sciences, LLC, or MSC for short, has a deep history in composites design and analysis dating back to its founding in 1970. In those early days, MSC focused on supporting DoD customers with micromechanical analysis of materials and composite structures. In the following years, the company has expanded to incorporate design, prototyping, and testing services. More recently, the company has grown even further and added larger scale composite and textile manufacturing capabilities as well. In 2018, Seaman Composites Holdings acquired MSC, cementing a long-term partnership with its sister company, Seaman Composites Incorporated, located in Gulfport, Mississippi. MSC is headquartered in a combined engineering, laboratory, and prototyping facility in Horsham, Pennsylvania, and maintains an engineering support site in Huntsville, Alabama. Specific areas of focus for these sites include design and analysis using FEA, mid-size composite fabrication, and testing. Both operations are supplemented by an advanced textile production and composite manufacturing facility in Greenville, South Carolina. MSC's quality management system is certified to AS9100D. The Navy Challenge. The Navy is increasingly adopting composite materials in order to reduce overall craft weight and design more efficient components. Depending on their disposition and constituent materials, these newly designed parts may be expensive or time-consuming to replace in the case of in-service damage. Thus, there is a need for procedural instructions documenting repairs of fiber-reinforced composite components on the next-generation air cushion vehicle, the Ship-to-Shore Connector, or SSC. An acceptable repair will need to deliver the same quality as the parent component, while requiring minimum amount of support equipment and low overall labor. Additionally, documentation should provide service technicians with the clear ability to differentiate damage types, distinguishing between on-craft and depot-level types of repairs. Void reduction and variation in geometric profiles need to be considered, as the crafts consist of complex, aerodynamically shaped parts. Operational need and improvement. Current Navy repair procedures for on-craft damage to fiber-reinforced materials need to be updated, as they refer to unnecessary procedures and, in some cases, obsolete material systems. Procedures are also limited in the size of the repair allowable, are expensive due to amounts of support materials needed, and are difficult to enact on landing craft attachments, creating logistical challenges for the fleet and onboard service members. As seen in the figure to the right, large, service-critical components of the next-generation air cushion vehicle incorporate composite materials in their design. These components see diverse loading and environmental exposure scenarios, which indicates the potential for a wide range of damage scenarios to account for. This compels a strong need to simplify on-craft repairs, minimizing steps and equipment needed. This would allow similar repair methodologies to be flexible enough to cover the spectrum of components on board. Technology developed. MSC will deliver a robust fiber-reinforced plastic component damage assessment and repair methodology document. Compiled as a comprehensive structural repair manual, it will detail procedures for inspection, damage evaluation, and repair for a wide range of on-craft damage. These include superficial damage, such as scratches and gouges, to penetrative damage of core composites due to in-service impact events. The repair manual will be accompanied by a flaw criticality handbook to guide craft inspector or technicians surveying the extent of damage. The flaw handbook provides detailed contour maps of composite components, accounting material fracture properties to predict the maximum allowable flaw or defect size. Depending on the extent of damage observed, this critical flaw size guidance will let the technician or UT inspector know what defect sizes to look for, and aid in the determination of the repair disposition. The repair procedures prepared will be specific to the latest design of SSC components, including the latest material upgrades. MSC is currently supporting the DoD through parallel SBIR efforts on SSC and LCAT component redesigns. Knowledge gathered, including material characterization and FE analysis, was leveraged in order to develop this flaw handbook. Current status of the program. A first draft structural repair manual was delivered to the Navy customer for feedback in the second quarter of 2020. Critical flaw analysis and mapping has been completed for all major fiber-reinforced components of the SSC craft, with documentation ongoing. As of the date of this presentation, substructure and full-scale component repair validation for some of the major repair procedures are ongoing. Target end dates and associated TR levels are listed in the table below. Pending customer feedback on the documents previously submitted, the final delivery of the structural repair manual is set to be done by the end of the second quarter of 2021. Market differentiation. There is little existing documentation regarding repair of fiber-reinforced composites for the latest SSC designs. Documentation that is available needs to be upgraded to account for enhancements in constituent materials made. The benefit of the Structural Repair Manual and accompanying Flaw Criticality Handbook is that it enables craft technicians to conduct high-quality in-situ repairs with a good degree of confidence in the integrity of the repair, thereby reducing potential craft downtime. Along with the aforementioned documents, repair material kit recommendations will be provided, featuring material candidates that will have been evaluated and demonstrated on subcomponent repair articles. Transition to fleet. This Phase 2 effort has a direct transition application. The repair manual and accompanying documents will be delivered to PEO ships PMS 377 for ship-to-shore connector craft. As of the timing of this presentation, funding is allocated through the end of the second quarter 2021 to allow for the remaining repair procedure validation tasks. Subcomponent and full-scale validation efforts are ongoing. Market analysis. As more and more legacy crafts go through redesign efforts, fiber-reinforced plastic materials are increasingly being relied upon to improve performance and part fabrication throughput. This reality provides MISC with further opportunities to apply its procedural methodology for future crafts. Steps taken to compile and validate repair procedures are transferable to appropriate craft featuring fiber-reinforced composites in their construction. The documentation delivered would be useful to meet internal quality requirements. Additional applications for the service would be in commercial marine craft, light non-structural composite aircraft industries, as well as some non-craft applications such as hardware, personal equipment. Transition partnership pitch. Ideally, MISC aims to continue working with Program Executive Office ships to identify additional crafts that require these sorts of documents. MISC is also open to connecting with further transition partners that require the service. This has been a summary of the efforts under this Phase 2 SBIR and the value that MISC offers. The nature of this methodology in that it is more of a service rather than simply a hardware development means that it can be applied to a wide range of applications, given the material makeup of the components in question. I'd like to thank you for listening in on my presentation. I hope that the information was clear and informative, and that we can find a way to collaborate together in the future. I have my information listed in the slide.